Okay, so the third one, let's, oops, hold on a second. These are the two cycles of the default configuration with Kp equals to 0.05, Ki equals to 1. And this is the ratio, this is the speed at about 125 rad per second or so, and the lower case is about 80 or 75 rads per second. So 75 actually it should be. So what you need to do is following the 7th question, measure the peak time. So the peak time of the measure one is about 140-ish, and also the percentage of overshooting to do the calculation for the percentage overshooting and of this measured SLD response. Okay, and also answer the following two questions, like what effect does increasing the specification of zeta will have on Kp and Ki, and thus will affect the waveform. Okay, and also the control gain, damping ratio, peak time, overshooting, and so on. And also the other question is what effect does increasing the omega 0 will have on the Kp and Ki, and further to the waveform, including the damping ratio, which is the damping ratio or the peak time or the overshooting. Okay, so I'll give you some, continuously give you some examples on changing the Kp and Ki respectively, and see the changes of this waveform. So this is the default settings. Okay, and if I again change the Kp to a larger value, okay, even larger, or simply just see if it goes larger, you can make a difference. Okay, if I reset it and change the Ki to something larger, you can see the difference between this waveform under this configuration with the waveform under the previous default configuration. Okay, and if I make it smaller, 0.5 say, this is making a lot of difference as well. And let me go back, oops, not 100. And if I simply make this one smaller, you can also see some difference. Okay, so you need to summarize the difference between Kp with changing Kp and Ki, and answer the question of changing zeta and omega 0, and how it will affect the waveform. Okay, and those parameters like overshooting, peak time, and so on. Okay, and the next one is the set point weight. So let me change this Ki to 1.5. Okay, so this is the waveform of when Kp equals to 0.05 and Ki equals to 0.5. And now let me change the BSP to 0.05. Okay, so you need to tell me what changes if you change the BSP. Okay, and set the parameters from 0 to 1. Okay, so now it's 0.5, and let me change it to 0.8. What will happen now? Okay, now I'm changing it to 1. Okay, you should have seen enough cycles, and let me go back to 0. Okay, let me try one more time, restart it. And 0.05, no, 0.5. You should be able to see some trend on this, okay? And also the last one is change the KP to 0.2, change the KI to 0, and change the BSP to 1.0. Okay, and compare the speed and the reference speed and explain why there's a tracking error. Okay, let me do this. And then it asks me to increase the KI to 0.1 and as an increment. So let me add a little bit. That's for one cycle. That's for the second one. Oops, too much. That's 0.4. I'm skipping 0.5, going to 0.6. 0.7, 0.8. There are some similarities, but you can still see the difference. Okay, so this is 0.9, and that's 1. Okay, you need to compare the difference between from 0 to 1 and answer the question, what kind of effects does this KI have on the measurement of the DC motor. Okay. Alright, so basically this is the second lab. You need to understand why changing KP and KI have these kind of effects on the waveforms, and also how this KP, KI are related to the omega 0 and the zeta. Okay. Alright, let us know.